We have to figure out which one is positive. So we're looking for a graph that is rising to the right. It's going upwards and rising to the right. I want you to write that word here, rising to the right. Which graph is rising to the right? Please do not call out. 1, 2, 3, 4, or 5. Yes.
5.
Excellent. So we would put 5 here. This would be number 5. Negative. How do we know if it's negative, Daniel? It's going down, so we would say it's falling to the right. Write this language down. It's important you understand the difference. It's falling to the right. Which number falls to the right? Yes.
1.
Number 1. Good. It's going down. It's falling to the right. Number 1. And the other one was rising to the right. Positive, increasing rate of change. So the first two that we just looked at were constant, which means they have to be a straight line. If it's constant, automatically, you know, write this down as well. It's a straight line, which means what? Straight line is, what's the word?
Linear.
Good. Okay, so the first two were straight lines. Now, if it's increasing, it doesn't say it's constant, but it's positive. So it would be a curved line, or a curve, not a line, sorry, a curve. Would it go up or down to the right? Yes? Good. So what number, Copper?
2.
Good, excellent. Number 2 is C. And now, what about no rate of change? Yes. Jen? And what kind of line is that? What's it called? Horizontal. It's a horizontal line. And the last one, negative rate of change. Not constant, but it's negative. Danica?
3.
Good. Raise your hand if you got perfect. Okay, now we're going to do this quickly because we've already done rate of change. Is the scale 1 for the y-axis? Is the scale counting by ones? Here's y and here's x. We're trying to find the rate of change. So we have to count what? Rise over.
Run.
So rise is the vertical distance and run is the horizontal distance. I'm going to do the first one and then I want you to tell me the rest of them. So we're going from A to B. So point A to point B, I'm counting the rise. Am I going up or to the right? So let's draw our triangle. So you know where to count. Then we're going to count the squares. And it's a scale of 1, so we can count by ones. 1, 2, 3, 4. Rise is 4. What's the run?
2.
1, 2. We can simplify that. What's 4 divided by 2?
2.
Raise your hand if you got 2 for A. Okay, so the next one has a rise of 2 over 6. We can write that in lowest terms. 1 over 3, excellent. And then C, D. Now this one's a little different because it's negative. What is the rise? I can go this way actually. 1, 2, 3, 4, 5, 6. It's going down. So is it positive 6 or negative 6? Negative 6. Raise your hand if you wrote negative 6. Over, what's the run? 1. So equals negative 6, not positive 6. Raise your hand if you wrote positive 6. Okay, so you had a negative.
6.
Because this is the line, C and D, it's going down to the right, which means it's a negative slope. The rate of change is the slope, remember.
Swap.
1 over 1, 2, 3, 4. Okay, what about BC? Yes? Rain? 2 over 2 equals 1. And the last one, Michelangelo. 1 over 3? Is that the rise over run? 3 over 1, which is equal to 3. Raise your hand if you got all 3 of these correct. Shh. Selena is walking home from the mall at a rate of 3 kilometers per hour. Does the rate at which she's walking change? Or does it stay the same? Is she walking at the same rate the whole way home? Yes or no? Yes. It doesn't say that it changes. So we know that it's going to be a constant rate of change. She's walking at the same pace, so automatically we know, is this graph going to be linear or nonlinear? Okay, so we can eliminate that. It can't be curved line, okay? We have to figure out which graph represents the relationship. Let's look at the axes. We're looking at a relationship between time and the distance from home. Now, think about this. If she's walking home, so towards her house, would her distance from home be increasing or would it be decreasing? Decreasing, because she's getting closer to home. So we can eliminate this one. We're left with C and D. Which graph do you think is the correct graphs? Raise your hand if you think it's D, C. Why? Well, she's traveling 3 kilometers for every hour, so use the graph to check. That's her the rate of change, remember, is the slope. Can we count the rise over run? Let's do this one. How does this go down? 1, 2, 3, 4, 5, 6, 7, 8, 9. Over, what's the run? What's 9 divided by 3? 3. That one represents a rate of change of 3 kilometers per hour. Does this one represent a change of 3 kilometers per hour? Draw your triangle. What does this one go down by? 1, 2 over 6. 1, 2, 3, 4, 5, 6. Is that equal to 3? No, that's equal to 1/3. So the correct answer is C. It's decreasing, Creel, and we know it's decreasing by 3 kilometers per hour, which is what the question tells us.